So it's a great pleasure to introduce John Coates, or to interview John Coates, the mathematician at Cambridge. John, when and where were you born?
So I was born in Australia on January the 26th, 1945, in the Australian countryside about 200 miles north of Sydney. And the reason why I was born there, I guess, was that my mother's family were Irish, and they had come to the Manning Valley, I guess, a little after the potato famine in Ireland. And my grandfather was English from Ilkley, and he came later. And so his farm, he actually was in the lucky generation that he still got a lot of land, but it wasn't on the Manning River Valley. And so it was one of these smaller side valleys off there, and I grew up. My father had been a high school teacher, but he was, for ill health, he retired, in fact, to part of my grandfather's property. So I grew up there, and
Do you have memories of your childhood there?
well, very vivid memories.
Tell me.
Well, in fact, my childhood was quite full of tragedy for my parents, in that my father had a series of mental breakdowns, and in fact, shortly after I was born, I had one brother, and so my mother had to manage the farm by herself and so on, and I think this proved too much for her, and so she died when I was 7 years old. And up until that time, my father had been very ill on and off, but he then took over bringing us up, and was in fact very, very good for about 5 or 6 years, his health, but then he did collapse again when I was about 13 years old, and became very ill again. So this whole period of my childhood was somehow punctuated by this illness of my parents. But the positive things were, of course, that it was totally unspoiled bush then, and there were the sort of thing which doesn't exist in the world today, sort of unlimited wild animals around, and in that sense it was tremendous for a little boy to grow up in that area.
Were you allowed to wander around freely?
Absolutely.
What about all those whatever they're called, funnel?
No, I think, like all children who grew up in the country, then your parents taught you certain basic rules, which the one I always remember was to make a lot of noise when you walk through the grass to chase the spiders away. But the truth is, nearly all of even though there were these poisonous snakes and spiders around, they were not at all aggressive. So there were no problems that way.
Were you interested in wildlife? Quite a lot of the people I've talked to early on got interested in.
Well, it's strange. It was so everyday that, in that sense, I guess we just took it for granted.
You didn't collect anything in particular? Or?
No, not at all. No. But somehow you saw it all the time. Whenever part of the farm was cleared, or when we had a couple of dogs, we used to go out chasing animals and things like this. But it's true. You just simply took it for granted. You didn't know that the world was going to change so much so rapidly. But I was fortunate because, in fact, I was educated. And my father was educated because my mother's family, who were Irish, even though they came from a very modest background in Ireland, for some reason the women had been educated, partly self-educated, I guess, and they zealously held on to this until my mother's generation. And so, in fact, my father his first wife had died, and so he married an aunt of my mother's. And so that's why it was through her influence that he was educated. and then similarly it came on. Then I guess it's through his influence and my mother's that I was educated beyond the basics that everyone else did.
I think you early learned a love of poetry from...
Absolutely. In fact, you see, it's very curious. I had no idea of much of mathematics or anything then, but they probably partly because they were self-taught. They were interested in literature basically, and so there were all the English classics were around there, and the Irish classics. They were very interested in people like Yeats and Synge and so on. And it was very nice as a child. It's true, we also there was a little public lending library in Turok that we used to go to as children too. My father used to take me there. But still, it really was somehow this nice thing that had come from the Irish side of my family.
Is there anything more we should know about the character of your father and mother as an influence on you, apart from the tragic circumstances? Your mother died
when I was 7 years old.
So you probably don't remember her very...
No, I do have very vivid memories.
Was she a warm
Very
person?
much so, yes. And in fact, when she died, I, in some sense, hardly knew my father, because he'd been away so much, and she was the person I was close to. But then he was tremendous in those years. The only sad thing, I guess, about my father was seeing him become very ill later in life. But I was also very lucky in that through in fact, I went to a very small school the nearest village was about 5 miles away. And I went to a very small school there until I was 11 years old. But then when my brother went off to high school to Tari, my father made big efforts, as this little village school was a perfectly sound one, but there wasn't much. I guess that it was one teacher and so on, so he made big efforts to get me to Tari Primary School for my last year. And interestingly, it's so crazy, isn't it? But at that time, the rules of the State Education Authority was that no child could go in a school bus, past a public school. So I wasn't technically allowed to be going by school bus to Tari Primary School, which was, it was a 15 or 16 mile journey, because it went past a school along the way. And my father fought that, and he actually won in the end, and somehow the local school inspector agreed. But then I was very fortunate, because the primary school was very good. We had a good class and a good teacher, and then the high school was excellent too.
Were there, I don't know how young the mathematics starts, but certainly Neil Turok, who I interviewed, by the age of 3, he was doing quite a lot of mathematics with his father, who was interested in mathematics in some form. But do you remember when you first started getting interested in it?
Yes, you see, it was the opposite with me, because neither of in fact, I think my mother, she had 1 or 2 mathematics books, and she was probably quite interested, but she had disappeared by the time I was able to do it, and my father certainly wasn't at all. So it was really only I guess, in my 2nd or 3rd year at high school, where I had an excellent teacher.
Do you remember the person's name? Or?
Jack Gibson was his name, yes. My father, in fact, had taught him French. My father taught French many years before, but he was an excellent teacher, and I went off, so I went right through Tari High School, and I was again lucky, because in those years, I think it was basically the Scottish education system, that it was still in force in Australia, in New South Wales at least. So we had a good curriculum. I learned some calculus, for example, at school, through the honours course. But I think it's true that from my childhood I was more interested in physics, largely because of the natural world. You see, at the back of my father's property there were quite high hills. And one thing that we used to do as children, we'd go back, and some of them were cleared, and it was volcanic, the area. So that one of the big excitements was to roll down these quite big boulders down the hill. And you get fascinated by this tremendous jumps of these huge boulders in the air. And so I think, if anything, I went off. Of course, I didn't. When I went to university, I had no idea even that there were professional. Of course, I knew that there were few university teachers in mathematics, but that you could spend your life doing mathematics never even really occurred to me.
What at school? Were there other things that you were particularly interested in? Particularly sort of hobbies? Were you beginning to get interested in music or sport or anything like that?
Well. It's interesting you say that. I think I had a latent interest in music as a child, but there was simply no possibility. If my mother had lived, then maybe, of course, she could have. She was very interested in music, but after that, there was no chance of learning out there. I mean, it was really quite isolated. So that was something which, and in fact, I've felt the loss. I like listening to music now, but the technical side of music has always been a closed book to me in that sense. But the other thing that we inevitably got caught up in at school, you can imagine a country high school then in the Australian environment, sport was a big thing. But it was nice in that there was a lot of camaraderie, and we used to play other high schools, and that side of it was very nice.
What did you play?
Well, the one which certainly played the biggest role, I guess, was I played rugby, but rugby league, yes, but nearly everyone of the boys' team, in fact, it was. There were others who played hockey. There was absolutely no soccer, football in that sense at that time. It hadn't come to Australia. And then we swam a lot in the summer.
In the sea or in rivers or both, I suppose?
Well, mainly in the sea. There was a small creek where next to my grandfather's house, where I lived until I was 7 years of age, but it was just, in fact, big enough to learn to swim. So, but then we, of course, at Taree there was a public swimming pool that we used to go down there for sport in the summer. But the wonderful thing was the coast, and it's certainly some of the most beautiful swimming coasts, I think, in the universe. I remember I was very disappointed years later when I moved to California, many years later. And one of the things that had made me choose it was that I thought the coastline would be like the Pacific coast of Australia. This was in Palo Alto I was living. And I have to say I was bitterly disappointed with not the beauty of the ocean, but as a place to swim. It was in no comparison to...
Yes, they are lovely beaches.
Another memory I have, interestingly, since we mentioned it earlier, is that my mother used to have a house at Port Macquarie.
Really?
But it was sold, I suppose, perhaps when I was about 5 years old. But up until that time, I have very nice early memories of going there. And also my mother's sister. And after my father became very ill, I spent a lot of time living with her. But at that time, she was living in a place called Papinbarra, which is behind Wauchope.
Well, my daughter, my stepdaughter, lived in Papenbarrow Road, which was the road up from Warhope. So must have been
Exactly.
very.
No, it's exactly that. That's the road which goes up there. So they, you see, her husband had, I guess, emigrated from England to Australia and then joined the Australian Army in the First World War and been very badly wounded. And he had been given a soldiers' settlement farm in Papenbarrow. But I suppose the truth was he was really too ill to work it. And in addition, there were the problems of the Depression. You see, most of those soldier farms were abandoned because of the Depression in Australia. But still, they kept it, and I think that's one reason why my mother had this house there, so that her sister could come down to the ocean. So I have very nice memories.
You must have gone past their house many times.
Probably, yes.
410 or something, Papenbarrow Road. Anyway, the last thing perhaps about school is that this is sometimes the age when people are at their most religious, but not always.
Isn't that interesting that you say that? Yes.
I wondered whether, or it's shortly after school that you sometimes go through a period when you question your religious background. What were your parents or your views on organised religion at this time?
Yes, it's quite a complex question. That my mother, the Irish side of my family were Protestants, even though they were from Southern Ireland, and in some sense I think they were quite religious. And my mother used to, I can remember when you talk about, do I have strong memories of my mother? I can remember as a small child feeling very, not upset, but sort of put out because she would go to play the organ in the little local church and I wouldn't be able to sit next to her, this type of thing. And at that time, I suppose, too, there was, they had come. I mean, it really, I suppose they couldn't have survived without religion. They had come to this virgin bush, and it was natural that they built a church, and they were, of course, that generation of people in Australia too, who had nothing when they came, knew they would never go back. So all of, I think, religion was very much part of their English heritage almost. And it's just like later on in life you see what happened in India, how important Christianity was there to the English who were in India. So it was quite powerful, but of course the whole of that Australia and that countryside, everything was changing as I grew up. That there was for example, even the Pacific Highway when I grew up was still a dirt road. When I was a child, it was still a dirt road. But everything, the prosperity that came in the Menzies era, you see, was beginning to change things. So. But I have to say, I never had any really strong. My aunt, my mother's sister, sort of tried from time to time with the very best intentions to somehow bring me more into the fold of the church, and my brother ended up quite religious as a result. But no, for me it was never a strong factor. No, that's perfectly true. Yes.
And still isn't.
Well, I think you see, that's a very complicated question. Certainly, any of these. Like, for example, I'm not a believer in the Christian religion, but I think one of the really interesting things about number theory is that it's so full of mysteries and unexplained beauties that you are conscious that there is something out there but it's nothing beyond that. I guess of all the organized religions that have intuitively attract me the most, Buddhism is is the one that it's more the beauty of Buddhist art and the fact that in Buddhism people tend to think and meditate much more than is much closer to actually mathematical work, I think.
So your answer about the beauty and the mystery, very similar to Einstein's comments on religion, that he didn't believe in any particular manifestation or organized religion, but he did believe in the wonder and mystery of something outside himself.
Absolutely, I would certainly totally feel the same way, yes. And I mean, in that sense, I think we're very fortunate to be able to spend our lives in which you see this type of thing. You see. I think it is one of the big charms of mathematical work, to see that very clearly.
Well, we'll probably come back to that later. When you'd finished at school, what did you then go on to do?
Well, it was, of course, I wanted to go to university the next year, and the one problem was getting money. There was also the fact that I guess life on the farm had been, because of my father's illness and so on, and that we were just living out there by myself, that I really got to the point that I wanted to get away from home. I was still terribly attached to my father and everything else, but it had been very difficult. And so what I did was that and of course I knew my father could not afford to send me to university, so it was clear I had to get a scholarship of some kind. But as soon as school finished, I took a summer vacation job at BHP in Newcastle, Broken Hill, the big mining company.
Oh, yes.
And in principle, well, one of the attractions was, as I say, I just wanted to get away from the bush and somehow meet different people and everything else. And this was one of the few practical ways that I could do it, because I guess they advertised in the school that they gave summer internships. And so I went down to Newcastle and started this job, maybe in I'm not sure exactly when it was, but sometime in December, I guess, after school had finished, after the leaving certificate. And I must have worked there until the until our leaving certificate results came out. And it was a very interesting experience, and in fact they saved me in some sense. Because if I had so what happened is they took a lot of people, I guess there were probably about 30 of us who came as to these internships. And then I think they chose at the end of the period about 2 or 3 that they would then fund through university, and you then went to university in Newcastle, I think was the idea. And you worked for them in the summer. And I don't know whether they saw that I was ill-suited for the work or whatever, but they did not choose me. But then that was more or less at the same time as the leaving certificate results came out. And I had applied for several scholarships, but one of them, which had been pointed out to me by the teachers at Turok High School, was that the Australian National University, which I didn't even know existed, had just started, they were just starting that first year, or maybe it was the second year, to take undergraduates. Before that it had been purely a research institution. And so they had some very well-funded scholarships that they had advertised, and I had applied for one of these. And I guess within maybe a week or 10 days of the leaving certificate results coming out, and when I was feeling very disappointed in Newcastle, not wondering what on earth how I would get off to university, I got a telegram from Canberra saying come down for an interview. And I guess that changed my whole existence then, in that I went down. I'd never been to Canberra in my life. I'd often been to Sydney with my father, not often, but we used to go perhaps once a year. And it of course, it was a totally new world, as you would imagine. We were put up in, and at that point, the university had excellent funding. They had this I don't know if you've been there, Alan, but they have this campus right in the centre of this. And Canberra was tiny at that time. It was like a sort of large country town, not all that much bigger than Taree, but they were very nice to us. And if my memory is correct, when we were interviewed, I think Howard Florey actually was present, at least for part of the time, because he used to come out as a visitor. He was the chancellor, I think, of the university, but I think it was Howard Florey who actually, and it must have gone, I think they brought down 20 people and they gave 10 scholarships. And we were all interviewed in one day. And then I went back on the train, a long train trip back to first Sydney and then up to Taree, just wondering, would the telegram come?
And it did.
And it did, yes. So,
and you, to read what? What subject were you going to read?
well, again, you see, as typical of Australian universities then, firstly, there was nothing like medicine at the ANU. I mean, there probably still isn't, I think. But at that time, you either took a straight arts or a straight science degree. So, in my case, I was going to read mathematics and physics and chemistry, general first year. And I think it's true that my feeling at that time, I had, as I say, it was all a completely new world, but I thought it was probably physics that I would do. Partly because, of course, you were conscious more, I had not much contact with mathematics, but apart from this excellent teacher. But also, physics had a higher profile because of everything. I mean, we all knew about the nuclear side of things. And even when we went down there, I think we were taken over because in the ANU there was, Oliphant had his big accelerator that he'd been building for 15 or 20 years, I think, already. And it all seemed to be, that's what science seemed to be. And then in my first year at the ANU, the truth was that the physics was not so well taught, and the mathematics was extremely well taught. And I guess it was from that first year onwards that I really felt that I would do mathematics, and I was very fortunate that at that time, again, they had just set up, because of this, the departments were just being set up in the undergraduate side of the university, but equally the ANU had decided to set up a department of mathematics in the research school. And so they were recruiting people, and I was very fortunate that Bernard Neumann came from Manchester. There were 3 German refugees who played a big role in my...
is that Neumann, N-E-U-M-A-A?
Double A, yes.
Yeah.
So that he and his wife, Hannah Neumann, so he became the head of the department in the Institute for Advanced Study of the ANU. And his wife, Hannah Neumann, agreed to take on, she was also, they both worked in a similar part of group theory together, but she became the head of the undergraduate teaching side, which was something which she didn't have to do at all. She could have perfectly well just gone into the research school as well. And then they also brought out to Australia another German refugee who had been at Manchester with them, Kurt Martin.
M-A-Y-E-R.
M-A-H-L-E-R, like the musician. And he came, so the turning point for me certainly was that I think in my, the third, maybe it was the second term of my first year, he came over and just, out of interest, taught us a course on elementary number theory. And it was really interesting, and from that time onwards, I guess I felt clearly I wanted to do mathematics.
Might be very helpful for me as well as the rest of the audience. If you could very simply explain what number theory is.
Yes, so number theory is I guess the study of the deep and hidden properties of the most basic of all mathematical objects, which are the integers, the whole numbers, the integers, and the rational numbers.
What is a rational number?
The ratios of integers.
Oh, ratios.
Like a half is a rational number. And even though these are, of course, a lot of mankind's evolution in mathematics, and partly because of the need for physics and calculus and so on, is that he's kept enlarging the number systems. But it's, I think, true that the deepest and most interesting and most mysterious properties of all in mathematics are there in the integers. So this, because it's dealing with these very basic objects, it's certainly the oldest part of mathematics. I guess only astronomy has, in some sense, has real competition with number theory as being the oldest part of mathematics. And it undoubtedly, you see, it's still true today, and some of the most important discoveries have still been made in the 20th century in number theory by people looking at numerical examples. But historically, this is how it all started, that people would look at numerical data and notice surprising things going on. And it certainly started in Asia long before the Greeks, in fact.
Yes, I was wondering
Yes.
how deep the roots were. When you say Asia, do you mean India, China?
Again, we don't know exactly, but probably India. But there was enormous interchange of ideas throughout Asia, as we know through Buddhism and things like this. But it's true, we have in the West, we tend to think of mathematics as starting. The Greeks, of course, made a great contribution to mathematics in that they were the ones who emphasized the idea of an abstract proof. But in number theory, even today, the goal of number theory is to prove these basic properties that people have noticed about the integers. Most of them are unknown. I mean, unknown in the sense of unproven. And their discovery was often made long ago. I mean, there is the sort of mathematics I have worked on was a problem. The classic example is a problem that was certainly studied numerically by Arab mathematicians 1,000 years ago. And it turns out to be a beautiful example of the modern theory. And it has practically nothing to do with Greek mathematics. It sort of antedates that. But we don't know exactly where it began or what. But it is the fact that there were certain patterns happening in numerical data that people noticed this type of thing first. You see a lot of number theory in the popular mind, and it is a fundamental part of number theory. A lot of the numerical data has been in connection with prime numbers. So prime number is one you can't factor at all. But I myself have worked more in what we call Diophantine equations, which is of course called after Diophantus of Alexandria, and that's the study of equations in integers. And there you have these very ancient problems that we still do not know how to solve today.
Will we?
We still don't know how to
No,
solve.
I mean, will we ever?
Of course, I yes. In that case, you see, there is this. When we were talking earlier about Swinnerton-Dyer, there's this he and Birch made this wonderful conjecture, linking these problems to something else. This classical problem is just a special case of it. And I do believe that sooner or later and there's been a little bit of progress on their conjecture, but I think in the end we will be able to solve that conjecture. I think we're all missing something rather simple in the case of this problem, but someone has to find it. So.
I mean, as a complete layman, I mean, to me numbers are things like 1, 2, 3, 4, 5, 6.
Exactly, to me too.
And
yes.
How can there be any mystery about them? I mean, they go on and you can have very large numbers and there's a question of whether they can be finite or infinite. But apart from that...
Well, you see, for example, straight away, the question of the distribution of prime numbers. So prime numbers are 2, 3, 5, 7, 11, 13, 17 and so on. They're numbers which cannot be factored.
Yeah, cannot be divided.
That's right.
Yeah.
When I say factored.
You factors, yeah.
And it's fairly easy to see, it was probably known long before the Greeks, that there are infinitely many prime numbers. That's not difficult to see. But the question of their distribution beyond that is still one of the great mysteries in mathematics. There are deep results known, but...
beyond what? Beyond...
Well, how many... So the real question is, how many prime numbers are there up to a large... Suppose x is some large number.
Yeah.
How many prime numbers do you expect to occur which are less than or equal to that number? So, and this turns out to be of real practical importance today too. Well, there's another problem connected with that which I'll talk about later, but we do know now that it's very roughly x over log x is the number of prime numbers.
X over
the logarithm of x.
Oh yes, yeah.
Is what this is a so-called prime number theorem. There's a precise statement of it. But that's not really the full answer. The full answer is that you really want to know how much the number of primes up to x differs from x over log x. You want to have some upper bound for that. And this turns out to be a problem equivalent to this, what's often called the Riemann hypothesis.
How do you spell that name?
Riemann. Riemann was because Riemann, it's on the face of it, he was the person who saw that there was a connection between this problem and the distribution of zeros of an analytic function that we call the Riemann zeta function. But in fact it was Gauss earlier who had made a guess that's closely related to the Riemann hypothesis, that in fact pi x was very close to what we call the logarithmic integral of x. And you can make that quite precise and give something equivalent to the Riemann hypothesis. But, so that's one problem. Another problem that's completely unknown about prime numbers is whether there are, so you get these prime pairs. So in other words, you get 3 and 5, 5 and 7, 11 and 13. So two numbers, p, a prime, and such that the prime plus 2 is also a prime. And it's still unknown whether or not there are infinitely many prime pairs. That makes any sense. Of course, everyone believes there is, and there's even an asymptotic formula and so on, but it's never been proven.
Fascinating. Well, we'll come back to some of this. Let's get back to the 20-year-old John Coates at university in his having discovered mathematics and number theory in his first year. Did you then begin to specialise in mathematics?
Yes, I guess in my second year, I think I just took mathematics and physics. I dropped chemistry if I remember correctly. And then I think in my third year, no, maybe I did do, I've forgotten, but it's true that it was 3 years in which I took progressively more mathematics. And then the fourth year, the honours year, I did only mathematics. And I was indeed very fortunate that I got interested in number theory through the lectures of Kurt Mahler. He came on a number of occasions and gave us, well, he came from the other side of the university. And then I started, in fact, I was able to start research as an undergraduate. In my fourth year, we were able to write an honours project, and he gave me an old unpublished paper of his. It was quite difficult because it was in German, and I only had a smattering of scientific German. But I read it, and it really gave me confidence, I guess, that I could. Because one of the real difficulties of number theory is that it's a vast subject, and there is so much to learn, and the problems, the interesting problems that are left are so hard, that a beginning student, you have to have a lot of courage in some sense. And I think a lot of what sort of gave me confidence to go on then was precisely this sort of time I spent in that year. And he was really very good.
He spent time with you?
Well, in the sense that he gave me this, he suggested that I do it, and I would go and see him, I guess, maybe once every week or two. And he made a couple of suggestions, and but I was able to do a little bit of original work of my own through his guidance that way. So that was very good, I thought. Curiously, I also, well, there were various other things, naturally, that happened as an undergraduate that were very...
You fell in love?
Exactly. I met my wife, and she arrived a year after me at the ANU. And so we were there as students together. And that was, of course, very, very nice. And then I guess I got a little bit involved in student politics and so on too. I have to say it was a really, the university was tiny at that time. And for example, Robert Menzies, the Prime Minister, used to come, somehow he really was interested in the ANU. So I have to say a total difference from, of course it wouldn't be possible today, I guess, for an Australian Prime Minister to come along, but Menzies used to come along to the Hall of Residence, Bruce Hall, that he had, I guess, he'd been instrumental in having it built and so on, but he would come along for meals and things like this. And in fact, my wife's father was also a member of Parliament. And this was before, too, they were just beginning to build up Canberra, but at that time it really was a small and very charming place to be in many ways.
What was your wife's subject?
So she was studying arts.
Arts?
And she concentrated in politics at the end.
You mentioned politics. Did you go on with an interest in politics?
No, not at all. So somehow or other I got sucked into the student politics that I guess that weren't... It was a very small community, and the main people who were involved were at the same Hall of Residence. And so I got sucked in a little that way. And again, there were a few things on the national level that I was involved in, but then after I made a deliberate decision at the end of my third year that I didn't have the time to go to do anymore, so I stopped.
And since then you stopped?
Completely. I've had nothing to do.
National politics or international politics?
Absolutely not. I mean, perhaps
college politics, perhaps.
A tiny bit of college, and when I was at the École Normale, I guess, there was a tiny, but not really even there. It was, when I was in Paris, one had to be a little bit involved in things, but not very much, not at all.
So you must have then gone on to do research? I mean,
exactly. So again, I was lucky that the ANU had a travelling scholarship that they introduced, just one, and I got it, and partly it was very interesting. I mean, the two people who sort of directed me into what I did next didn't direct me, but they somehow, it grew out of that, were Mahler, who was this number theorist, and then Hannah Neumann, who was a group theorist. And it's sort of curious that they were on the opposite sides of mathematics, that she was sort of interested very much in abstract algebra and the new things, and Mahler was of this sort of great German school of number theory, and I think I can say it without offending anyone now, but she told me once, you can't, you're crazy to go into that scene, it's sort of very conservative, very old, very difficult. You should be going into this part of mathematics, you see. But she was a very straight-talking lady. In fact, I liked her very much, but she was a very fine mathematician in her own right. But so somehow, because of this tension between the two of them of what I should do, I ended up, they suggested that it might be a good idea rather than, one possibility was to come to Cambridge directly. But the other possibility was to go to Paris, where there was a sort of very vital school of much more abstract algebraic geometry going on. And so that's, and with the ANU travelling scholarship, you could go where you wanted. So again, Mahler, I think, wrote to some of the mathematicians in Paris, and I was given a place of a foreign student at the École Normale for a year. In fact, I think it was a year initially, and so I went to Paris. But, as you can imagine, it was, somehow it was an experience for me, but it was quite a shocking experience in many ways to go to Paris. For example, I had never lived in a big city. My wife, her family, she joined me after she had to finish her honours year at the ANU, so she joined me after 3 years. But I had never lived, even though she lived in Sydney, I had never lived in a big city before. But I guess the really difficult thing for me was, the language was not too bad. I mean, I had learned, I could read French fluently because of my father, but I had never spoken very much French. But basically, I guess I found I did not have the mathematical background to sort of cope in some sense with the type of research that these people wanted one to do. So I in fact, I became very frustrated and felt I had to change after a year. And at that point, again, I was very fortunate because I guess Ian Castles had come to Canberra when I was there, and Mahler had talked to him about me, and that's why I had been offered a place in Cambridge. And so I wrote to him.
Ian Castles?
Ian Castles, yes.
C-A-S-S-E-L-S.
C-A-S-S-E-L-S, yes, he's still here.
Yeah.
So I wrote to him saying I really couldn't, found I was, just out of my depth in this very abstract world in Paris, and could I come to Cambridge? And he was very kind. He immediately wrote back and said, yes, there's no problem at all, you can come.
How nice.
And so I stayed we spent the whole year in Paris, but then I came in that summer.
I mean, this is just a very general question, but it's been noted that the French are very good at pure mathematics, that something like they've won twice as many Fields medals in mathematics as the British. Is there anything about French society, apart from the wine, to which you can attribute this high ability in mathematics? Or do you think it's a myth?
No, I don't think it's a myth. Of course, I think France did have a golden period in certain aspects of its intellectual life after the Second World War. There was this whole generation of people who suddenly grew up liberated like that. And it was obviously different to what happened in England, I guess. But so that they had a particularly strong mathematics. And they also very much pursued this idea, which is of course very important in mathematics, that one should be more abstract and of course build up mathematics axiomatically and so on, which is still there, but it's something that everyone takes for granted now, you see. But the French somehow had the right people and the right themes, and but curiously, that I was very fortunate because I'd already heard about it when I was going, but at the same time all this major abstract work was going on in Paris. There'd been this great number theoretic discovery made here in Cambridge by Swinnerton-Dyer.
By?
Swinnerton-Dyer.
Yeah.
And that already had, of course people were aware of this the world over, because the leading people immediately became interested. And so that was a little bit in the air when I was in Paris. And I was very interested in it myself too. So that it was happening in a very different way. And this discovery was made in no sense by because it was about some of these oldest problems, but not by big abstract machinery like was going on in Paris, but by numerical experiments on the first computers.
EDSAC.
EDSAC and things like this. So there were very important questions going on both sides of the channel. But of course I went back to France later on. I taught in Paris for 8 years. So you question of one of the reasons why there is no doubt why French pure mathematics has been so good. I don't know so much about the applied mathematics, and has been the École Normale Supérieure, which is undoubtedly has been a great training ground for pure mathematicians. Always, but particularly I think since the Second World War. And I guess we all hope it will continue that way.
Can you remember your first impressions of Cambridge when you first came here? It wasn't a big city like Paris.
No, in fact, we did come over from Cambridge to Cambridge once as tourists beforehand. Well, it was very nice. I mean, we arrived in midsummer, and I was a student at Trinity, and they had flats at that time above the Blue Boar, what used to be the Blue Boar. So we had a nice flat there, and then we couldn't stay there when it had already been promised to someone else when October came. But then we had a delightful flat in Westminster College, above the Master's Lodge that they just rented out. At that time, I don't know if you ever knew her, but there was Mrs. Burkhill ran the Society for Visiting Scholars in Botolph Lane. And her husband was a mathematician, but she just helped students who weren't housed by their colleges or whatever. And someone said to her, "You should go and see. They have a list of accommodation." And she sent us up to Westminster College, and we had the most delightful flat there. I often tell my research students that my standard of living has declined ever since I was a research student.
Did you have any of that sense of being out of your depth when you came to Cambridge?
Well, you see, it was completely different. That I then decided, because I only had 2 years of funding left,
Mm.
that the only practical thing for me to do was to abandon the sort of work that I'd been trying to do in Paris and leave it for the moment, and write a PhD thesis much more closely related to the sort of work I had done under Kurt Mahler for my honours thesis. And so that's what I did.
This was an honours degree, in other words, it wasn't a PhD.
No, this,
Oh, I see, yeah.
I was doing this
Yeah.
is my honours thesis
Yeah.
in Canberra.
Yeah.
And I was, there was someone in Cambridge who'd done some very interesting work in that direction. And so I wrote a thesis. As I say, I didn't have much time. But I have to say, I'm infinitely grateful for the nice atmosphere in the department then. And
Did you say who your supervisor was?
Alan Baker.
Alan Baker. He's had quite an influence on you?
Well, no, not really, because in the sense that I did, what I really wanted to do was the type of more algebraic number theory, and already I was very interested in the conjecture of Birch and Swinnerton-Dyer, and Swinnerton-Dyer was here, and again he was someone whose lectures I attended. It was marvellous then that he had, I guess he was the Dean of Trinity. He lived in Trinity, and he had the room over the gate at the back of the college, so with a beautiful view down there. And I think every afternoon it was quite certainly any mathematics student, but I think any student could come and have a drink with him at the end of the afternoon.
Wonderful. You mean alcohol drink? Or
well,
tea?
yes,
Or
I mean, certainly there was alcohol if you wanted it. So I guess I used to go maybe once a week or something. And he was very open, and I always appreciated it very much. Yeah.
well, he, as you mentioned, was a great mathematician, but it fits my stereotype. The one mathematician I knew quite well used to say that you can't do mathematics, high-level mathematics, for many hours in a day because it's so intense. So he used to drink quite a lot because he was just really filling in time until he could get back to the mathematics. But he sort of rationed himself to 3 or 4 hours a day of this stuff. Is there any truth in that or not?
I don't know. But by the way, of course, Peter himself drank very little, I think.
Yes.
And he was, by that time, he was doing a lot of mathematics, and did also some very work that was subsequently very important, but he was getting heavily involved in university administration then too. But to answer your question, it's...
How many hours a day of mathematics can you do?
Well, it's true that in terms of sort of real mathematical work, and trying to do something new, or just working out on a paper, that it's perfectly true that sort of 3 or 4 hours a day is probably your effect. You're not, unless you're very excited, and then you can work sometimes for a long time. I find I can't work too much more than that. But then there are all the chores of the academic world, which involves some, like the endless writing of letters of recommendation, or even preparing a lecture and so on, that you the reality is, I think, if one wants to leave time for real mathematical work, you have to be working long hours in the day anyway, and some of it, of course, it would be ideal if we could do it all when our minds were fresh, but it's not possible. And in my case, it's sort of strange, I often find, and I still do it, but for practically all my life, I ran a little bit in the evening when I was mentally very tired. And then I would find, when I was younger, that would wake me up, mathematics.
Interesting.
Now I find it puts me, it's very good for one, but it doesn't, I'm too tired.